More particles. Another particle problem here. So we got two particles. We're given two position functions. And now when I read the first one is asking us find all the times t during which particle r is moving to the right. Now, if you want to know which direction a particle is moving, you need to know its velocity. So the first thing we're going to do is we're going to find the velocity of the first particle. No, actually, it's the second particle. It says particle r. So I need to find out what r prime is, because when r prime is negative, we're moving to the left. When it's positive, we're moving to the right. Velocity functions or velocity numbers actually don't just show you or tell you the speed, they also tell you the direction. So that would be 3t squared minus 12t plus 9. All right, so what I need to do here is I need to create a sine line graph. Now remember, calculus, the College Board doesn't like the sine line graph as a justification. So luckily this question isn't asking for that. It's not asking for a justification. So I'm going to go ahead and set this guy equal to 0 and solve it. Let's say 3t squared minus 12t plus 9 equals 0. Notice that I didn't say that this equals 0. I don't want to say that because that's not true. R prime does not equal 0. And then I can divide both sides by 3, so I get t squared minus 4t plus 3 equals 0. And when I factor that, I get t minus 3 and times t minus 1. That's because negative 3 times negative 1 would be positive 3. And then when I add those two, that gives me negative 4. So I set those equal to 0. Looks like I get t equals 3 and 1. And so when I draw a sine line graph, I have 1 right here, and then I have 3 right here. I'm going to test 0, I'm going to test 2, and I'm going to test 4. It doesn't matter what numbers you pick, just as long as they are within those intervals. And what I'm going to do is I'm going to plug these numbers back into r prime so I can see if I get a positive or a negative number. Because of monotonicity, any number before 1 will have the same sign as when I plug in 0. Same with that interval and same with that interval. So when I plug in 0 to this guy right here, actually I could plug it into that, or I could plug it into this guy right here, because those are equivalent. Let's see, if I plug 0 into this, that would be negative 3. If I plug 0 into that, it would be a negative 1. Negative 3 times negative 1 would be a positive number. So that's positive. If I plug in a 2 right here, that would be a negative number. If I plug a 2 right here, it would be positive. So that's a negative times a positive. That means this is going to be negative. And then if I plug a 4 right there, that'd be a positive one. Plug a 4 right there, that'd be a positive number. Positive times positive is going to be positive. So it looks like all the t's between 1 and 3 is where we would be moving to the left. So I go ahead and write that for my answer and read the next question. All right, for the next question, it wants to know when the particles are traveling in opposite directions. So I'm going to create another sine line graph, but I'm going to do one for p, and then we'll compare the intervals. Now when I take the derivative of p, I got to remember that I have a function inside of a function. Pi over 4 times t is a function. And so first I take a derivative of cosine, so it's going to be 2 or negative 2 sine with the pi over 4t on the inside, and then I have to multiply this function by the derivative of the inside. That's the chain rule, and that gives me pi over 4. Simplified, that would give me pi over 2 sine of pi over 4. And what I'm going to do there is I'm going to set that equal to 0 so I can solve for the x-intercepts. And to do that, I'm going to divide both sides by pi over 2, so the pi over 2 doesn't matter anymore, actually. And then my question is, where is sine equal to 0? So I need to know where this equals angles that would give me a sine that equals 0. So I know that sine is equal to 0 at 0, and sine is equal to 0 at pi. For the first one, I get t equals 0. And for the other one, I multiply both sides by the reciprocal of pi over 4. I get 4. So I got 0 and 4, which does fall in the interval that I'm given. But I do know that sine is a periodic function, so I want to double check that I don't get another one, another number within that interval. And to do that, I need to know the period. So I'm going to take pi over 4, and I'm going to divide 2 pi by that number. So pi over 4, and when I do that, that's the same as saying 2 pi times 4 over pi. The pi's would cancel out, and now I have 2 times 4, which is 8. So the period is 8. If I add 8 to 0, I get 8, which is more than 6. It's outside of our interval. And the same thing with 4. When I add 8 to 4, I get another number that's outside of the interval. So drawing another, actually, you know what? I'm going to draw my sine line graph underneath this so I can kind of draw my numbers in correspondence to the other ones. This is just a 1 right here. So I have a 0 and I have a 4. Now I got to plug in my testers, a 1, and I'll do a 5 right there. Okay, so let's see, -2 sine and pi over 4 times something. Okay, so first let's try -1. If I plug in -1, I get sine of negative pi over 4, which I know is a negative number. That would be -2 times negative rad 2 over 2. And if I multiply those two, I get a positive number. So this is positive. Now, if I don't plug in a -1, but let's say I plug in a positive 1, that's going to give me a positive rad 2 over 2. So that's going to be a negative number. And then for the last one, I got to plug in a 5. If I plug a 5 into that, it'd be sine of 5 pi over 4. And I'll take the time to go over this one a little bit more, times -2. Okay, so if we remember our unit circle, this would be pi over 4. If we're trying to do 5 pi over 4, it helps out to remember that this is pi, which means, like if I went all the way to this, that would be pi. That means that this is 4 pi over 4. And if that's 4 pi over 4, I just need to go one more pi over 4 to there to get me 5 pi over 4. So that means this would also be negative, okay? The reference angle for 5 pi over 4 would be pi over 4. So rad 2 over 2 is the value of sine at pi over 4. And since the 5 pi over 4 is in one of the bottom two quadrants, that's where sine is negative, we would get a negative rad 2 over 2. So we have a negative times a negative again. So that's going to be positive. So we need to find out where our signs are opposites. So I'm going to draw another number line. I know on the AP exam you don't have the privilege of having all these different colors, but this really helps if you could draw everything on one number line. So I drew all my numbers that I got from the previous two number lines, and for each of these I'm going to draw in my signs. Now let me do the black signs first. It says that we're positive before the 1, so everything before the 1 I'm going to put a positive. And then it says between 1 and 3 we're negative, so I'm going to go ahead and put a negative right here between 1 and 3. And then it says after 3 we're all positive, so I'm going to put a positive and then a positive. Now let's do the purple signs. Before 0 we're positive, and so everything before 0 I'm going to put a positive for that one. Between 0 and 4 we're negative, so I'm going to put a negative between 0 and 4 for each of those. And then after 4 we're positive. So where are our signs opposites? Not there, right here. So we have between 1 and 0 and between 3 and 4 our signs are opposites, so that's going to be our answer. We're going to say when t is between 1 and 0, oops, I wrote that wrong, 0 and then 1, and when t is between 3 and 4. So those are my answers for the second part. Okay, the next question is asking for p and whether or not, or the acceleration of p. I should underline acceleration, it's key. So that means I'm going to take p and I'm going to take another derivative of that. So a, b, c. So I have p prime, or double prime, and let's see what we get here. We have our p prime, and we do have something inside of sine, so we got to remember to do our chain rule. So first we do the derivative of sine. That's just cosine, and we have the negative pi over 2 multiplying to it in front. and then you have the pi over 4 inside the cosine. We don't touch him yet. And then we multiply this whole function by the derivative of pi over 4t, which is just pi over 4. Pi over 4 times pi, negative pi over 2, would be negative pi squared over 8. And then we have cosine pi over 4t. Now this is the acceleration function for the second or the first point. Yeah. Okay. Now the question is, at 3, are we speeding up or slowing down? Now this is key. If we're speeding up, that means the sign of acceleration and the sign of velocity are the same. If we're slowing down, that means the sign of velocity and the sign of acceleration are different. That's important. You're not just looking for a negative or a positive of only the acceleration. You want to see if the signs match. So if they're the same, or like positive for velocity and acceleration, then we're speeding up, or negative for velocity and acceleration, then we're speeding up. Slowing down would be a positive negative or a negative positive. All right, important to know. So all I got to do is I got to plug in 3. So p double prime of 3, what does that equal? I plug in 3 right here for t. That would be cosine of 3 pi over 4, which is negative rad 2 over 2. And I'm multiplying that by negative pi squared over 8. Now the negative is not being squared, just a quick algebra reminder. Because there's not parentheses here, only the pi is being squared. All right, so that's a negative times a negative, which means we're going to get a positive. And so at 3, what is the the velocity? Now that's for the p function, so that's my purple right here. So 3 is right here, and it looks like we're negative. And so we have a negative positive happening here, a negative velocity and a positive acceleration. This means, therefore, it means we are slowing down. Now, for the last question on D, it's asking for the average distance. Now, there's two key things here, the word average and distance. Now, we know that R and P, if we plug in numbers, values of T, we will get a distance for each of them. We also know that with average, what you have to do to find an average is you have to total the distance, or you have to total the number and then divide it by however many numbers you're adding together. Now with calculus, you could do something really neat. This integral sign means, like if I say the integral between 1 and 3, that means we're going to plug in all the numbers between 1 and 3 and add them together. That's what the integral sign does. Now, if we want to find the average distance between the two particles, we would have to subtract the two distances from each other. It doesn't matter if R is first or P is first. You just have to subtract them. And so if we were to plug in the 1 to each of these, just 1, if I plug in the 1 to each of those, we would get a distance for P, and then we would get a distance for R, and if we subtract them, then we would get the distance apart, right? Okay, so if that's true, if I do this, the integral of that difference, this function will plug in all the numbers between 1 and 3, find their values, and then add them together. Okay, and that's what we want to do. We want to keep plugging in a bunch of different numbers between 1 and 3, subtract them, find their distances, add them together, and then we have to divide them. And what are we going to divide them by? We're going to divide them by the distance between the intervals. So we're going to divide this by 2. And I'm going to write it like this instead of putting a 1/2 right here, but you can put a 1/2 right there too. That's the same. Now, there is a trick here though. You got to remember, sometimes P is bigger and sometimes P is smaller than R. And so that means if you subtract them, like if it was 5 and then 3, that's a positive number. But what if it was 5 and then 6? Then that's going to be a negative number. We don't want negatives. We want all positives. And so what we're going to do is we're going to make all these differences into positive numbers so that when they're added together, they're summed up properly. And then we put our dt right here. Boom. This expression will find the average. And I think that's all we have to do. Yes, we just have to write the expression. We don't have to evaluate it. So there you have it. That's the final answer. And just to recap, this finds the sum of the distances between the two particles, and this dividing by 2 finds the average. How come it's a 2? Because that's what 3 minus 1 is. The integral sign stands for S. That is a sum, the sum of all these numbers added together. Well, that's what sum is. I guess I don't need to say added together. But anyways, there you go.